Hi, welcome to Getting Started with Data Science and Microsoft Fabric. I'm Brian Hitney, a solution architect focused on data and analytics. I'm going to use an example that is part of our real-time analytics lab. This way you can download the sample and try it yourself. And also, if you come up with something interesting, be sure to let us know. We'd like to check it out. So this scenario has us generating some fictitious stock data for Abacost Financial Group. This is a bit of an homage to Abbott and Costello, and you'll see the stocks named who, what, because, and so forth. So the first few modules of the lab are generating real-time dashboards like you see here. In this case, we'll use the data science capabilities to do some exploration of the data and try to make some future predictions. Now, in our sample, what we're doing is we're splitting the data into a little bit of a Lambda architecture here where we have our event hub that comes in, and we're going to split the hot path into our KQL database like you see here. This will be for our real-time dashboards and reporting. And then also into our Lakehouse where we'll be able to do more processing of that data. We could do additional processing of the events if we'd like to using the event stream, but for the purposes of this demo, this is our architecture. So we'll switch over to the stock analysis notebook. The first thing I'll call out is that we're always going to be updating this notebook with better documentation and so forth. So if you go to our lab and download it, it might appear a little bit different as we improve the documentation. First thing we'll do is we will import some of our requirements, which include the profit library, which we'll explain in a little bit, and then any other functions as needed. And what we're going to do, because we realize that even though our data is feeding our lakehouse, we need a lot of data to train off of. So unless we start our sample and then come back in a year to give it enough data for us to train off of, we've put a bunch of these files. We went ahead and ran this in a little bit of a time condensed way, and we put all of this data that can be downloaded. And that's what this step is going to do. It's going to go out to our storage account, and it's going to grab the stock history for a couple of years and then extract everything in CSV format. And that's what this is setting up, all of these variables. And we're going to then specify the stock symbol that we'd like to analyze, because we're going to pick a stock. Every experiment that we're going to do is going to look at only one stock in the group. And what I think will be interesting, I'm going to change this to the I don't give a darn stock. Oops, typed that wrong. So the GD stock. And see what happens, because I usually do this with the who stock, so I'm kind of familiar with what that looks like. I haven't done this yet with IDGD, I don't give a darn. So we'll see how that goes. And what I'll do is I'll run this, and I'll talk about what's happening through the notebook as we go. And I might fast forward a couple of spots if there happens to be a long-running task. So with our variables set up, what we'll do is we'll download the stock history and the data files. Now, all of the stock history is available, so it doesn't matter which stock we pick to analyze. It's all part of every stock is in the data. And what this will do, this ran really quick because I've run this before, so we actually already have the data downloaded. If I look in our data lake, you could see that here under stock history raw, there's CSV files, one for every day basically throughout 2023 and 2024. So all that data will be there for us to look at. And if we've already downloaded it, obviously it'll skip downloading it. The next thing we'll do is we're going to read that into a Spark data frame. So we'll specify the path for it to load, and we'll output the last 8 rows of the data frame once that's done. And then the next thing we'll do while that's finishing up is we're going to filter out everything except the one stock that we're concerned about, which is our I don't give a darn stock. So we'll go ahead and run that cell next, which should happen any moment here. So we'll see that we have all the different stocks here represented in our data frame. And then finally, when we filter out everything but the I don't give a darn stock, we could see that we're now limiting it to shrinking our data frame down quite a bit. Now, we don't actually have to sort by timestamp because the machine learning model will automatically do that by looking at the timestamp column that we're going to pass in. But when we're doing data exploration, it can often be handy to do some to be looking at it already sorted. So we'll go ahead and sort the timestamp column, and then we'll be able to see the latest value. And as I mentioned before, we have all of the data for 2023 and 2024. So we have a lot of future looking data here. So what we're going to do then next is we're going to truncate everything that's before today. And we could override that if we want to specify a certain day as an example. But if I go ahead and run this, we'll see that it will truncate everything that is before today. And today's December 1st. So we should have everything going up until November 30th, which is exactly what we have up until 23:59 in the evening. Now, the next thing we're going to do is we're going to convert this to a pandas data frame. So we'll go ahead and run this cell rather, and we'll see the minimum and maximum date time columns in here just to, again, have a data point to look at. So we can see that our first row has a day of January 1st, 2023, and then finally ending on November 30th. And that's exactly what we would expect. So that's our data window that we have to work with. So not quite a year, but pretty close. That'll be enough for us to train off of. Now, the other thing that we're doing with our pandas data frame is we're renaming the columns. By default, our columns have the name timestamp and price for obviously the timestamp of the record coming in, and then also the price. But in data analysis, these are often called DS and Y. So we're going to rename them because that's what Profit is going to require. And then we'll also, any other models often use that same naming convention. So we'll have to switch that. Now, also, it should be noted that the reason why we're changing to a pandas data frame at this point is, and performance-wise for this example, it probably doesn't make much difference. I actually haven't run this to see if there's a big difference, but generally speaking, a Spark data frame is going to be a little bit more performant on large volumes of data compared to Pandas. But for analysis, oftentimes it's easier to have it in a Pandas data frame. So oftentimes, pattern is you'll see loading a data frame using Spark and then converting it to a Pandas data frame once we have a smaller set of that data. So at this point, what we've done is we've really just loaded the data. We've done a very, very small amount of organization of that data. One thing we could do, and we're going to do this a little bit more in depth in a future video, but we can also do all of these steps that we've done here in terms of cleaning up, filtering, sorting the data inside Data Wangler in Fabric. So I've clicked on the Data tab, and if we click Transform Data in Data Wangler, you'll see that it picks up all of the different data frames that we currently have. And what's cool is a new feature. This is, I think, within the last few days, actually, that Spark data frames are supported. The initial release of Data Wangler only supported Pandas data frames. So that's pretty cool. We could see all the data frames that we currently have. And so if I select the DF Stocks Pandas data frame here, we're going to load that data frame inside Data Wangler. It will generally filter the results to the top 5,000 rows as an example. But what's great about this is we'll have the opportunity here to examine all of the data. We could then change the data types. We could sort the data. There's a lot of things that we could do on top of everything that we wanted to do, from changing column types, filtering, sorting, aggregating. We can look for outliers and correct missing data. We could do all of that inside Data Wangler. But that's going to be a topic for a different discussion. So far, everything that we've done has been directly here in our notebook. Okay, so let's keep moving on. So we finished loading everything, and we have our data frames and so on. The next step then is for us to start training our model, and we're going to use Profit to do that. And we'll talk about that in a second because this can take a little while to run. We'll kick this off with some of these variables. We'll start training the model, and then we'll discuss what's happening. So Profit was developed by Facebook's Core Data Science group. It's an ideal way to do time series forecasting. That's what it was built for. So if you have sales data and so on, it's a great thing to plug in to try to generate some forecasts off of that. Now, the other thing that makes Profit an ideal choice for us here is that Profit is univariate, which means it's only going to look at one data point, and that is the price of our stock at a given point in time. And that's really all we have, right? Because the data coming in, we have the price, we have the symbol, and we're filtering that to just ones, and we have the timestamp. So we really only have one data point to work with. And that is great for us in this case to have a univariate modeling approach. But in another scenario, we might want to include a lot more variables. Like, for example, does weather or does news events, things that are going on in the world, right? What kind of correlations can we draw based off of that might influence our stock price? Now, that's beyond what we have here, and plus, this is a fictitious example anyway. So any kind of events or anything else that we create would be constructed events anyway. So it just makes sense to stick with a very simple modeling approach here. And so what Prophet is going to do is there's a few variables such that can influence the seasonality and how strong some of those factors are, if there's weekly seasonality and so forth. So all these variables can be changed, and they're all documented inside the Facebook docs that we'll have links for here that we can look at. And what we're going to do is we're going to start up Prophet with those variables that will help influence how much of those variables will have weights in determining our model. And then we're going to pass in our pandas data frame into to fit the model, basically. So then what Prophet is going to do is it's going to look at all the data and try to make a model that fits based off of our criteria. Now, in order to build a future data frame that we can use, Prophet has a make future data frame function that is really handy for testing our data and building essentially a future looking example for how we can see how well our data fits. We could obviously build a data frame pretty easily just by creating a loop and putting in some test variables. But it's really handy to have this because we know that we want to take a reading every 1 minute as an example. So we could do 60 times 24 by 7. So that'll give us a 1 minute reading for an entire week. So this then lets us create a data frame for 1 full week into the future. Once that's done, then we'll do a forecast. We'll predict the future basically using our data frame, and then we'll plot all of that out. So you can see that completed. Now we have a lot of data points in here. So admittedly, this is a little hard to look at, right? Because there's so many data points of our stocks bouncing all over the place. I mean, this is Abbott and Costello. So we should assume we're going to get a lot of variability. And if we were to zoom in on this, we'll see exactly what's happening with some of our predictions, but we can scroll down and look at some better detail here. So that's what we're going to do, is move on and look at plotting some of these change points out specifically. And so we could change how Prophet looks at the different change points, which we've done here, and then the trend of the data. It's still a little high level, difficult to look at with the amount of data points that we have in there. But this lets us influence some of the seasonality impacts of our data. And we'll go down and also then plot the components of our forecast, which then gives us a much cleaner look at, for the next week, since today is December 1st, the overall performance then of our model, of our expected model. And we could see here that the expectation is then sometime late Wednesdays, we're going to see a real large spike in the price, and then also daily over the hours of the day, we could see the modeling of it as well. So that's what Prophet has come up with, and that's what it's seeing in that data. So this is the first time I'm seeing this as well. So we'll see how well this performs here in just a minute as we look at the data. So what we'll do is we'll look at the forecast then, looking at the head of that data, and we'll see the output of what Prophet has come up with. And there's a lot of different things. You can see the trend, and then we'll see a bunch of y-hat values. So we'll see the lower, the upper, and then all the way on the right is actually y-hat itself. And actually, this is the value that we're most interested in, because y-hat is our predicted value. So at this given point in time, which I have to scroll over for you to see it, but it's predicting that the price will be this 673 here at midnight on 12/1, which we're actually already past that. So it'll be interesting to see then how accurate this was if we look at the data, which we will do in a moment. So we can see all of this data coming in, but for the purposes of us and how we're going to use this data, the main data point we're going to look at is y hat. That's the most important piece of information. So that's what Profit has come up with. Now the next thing we're going to do is we can use say Plotly in this case to look at the predicted y hat value over time. So essentially taking everything that's in our future data frame and plotting that over the next week. And we can see that this is what it's thinking is going to happen. So we see that we take a dip every day of the stock, and then sometime late on this 26, it's going to have an increase. So you can see that should correspond. We're just plotting this manually in our own code, but you can see that matches pretty well with what Profit was predicting as well. This is the Profit built-in plotting, so it should be the same data. So okay, so now we see what we think is going to happen. Now, normally what we would do when we're building a model is we would want to not take all of our data and build the model from that. Usually we would hold some of that data back and do some training of that data where we would take all of the training data, say roughly 80% of it, give it to the model, and then test it with, say, our remaining 20%. So we could evaluate how well it does. Now, we could certainly do that, but Profit has some cross-validation built in to it. So let's go ahead and start running this while I talk about it. So what the cross-validation does is exactly think of it as splitting your testing and training data sets. And the nice thing about that is that we can specify a number of variables so that it can test many different points in the timeline for us. So we could see how well it performs over many periods of time. We could test for seasonality, say every quarter or every day or every week, however we want to specify it, we could do that. And then it will run through as many variations as we've specified in order to generate a performance metrics, right, that can calculate things like the standard deviation of our error and so on. So the way it works, though, is that we have the pass in the number of days that we're going to validate, and then we specify a period and a horizon. So essentially what the period tells it to do is how often do we want to look at training data. So in this case, we're going to look at it every 7 days. And then we're also going to do a prediction, the horizon, every 7 days. So if we were forecasting sales data and we wanted to look at it every quarter, we might say, okay, look at the last year of data. So we might say 365 days. And then every 90 days, look at, say, 1 week's worth of data. So then the period would be 90 and then the horizon might be 7. In this case, I'm mostly concerned about what's happening right now. I don't really care about what happened back in March. The most recent data is the most important. So what we're going to do is we're going to look at how many days in total do we have to train off of. And I'm going to subtract 14 days from that. And that gives me 319 days. So we have 319 days of training data. And I want to then use the last 14 days essentially as my testing data. So by specifying a period and a horizon of 7 days, I should have two essentially forecasts that the cross-validation should be able to make. And you can see that while this is running, this will take a while, it is making two forecasts with cutoffs between 11/16 and 11/23. So that makes sense, right? That's going to take the first cutoff, and then the second cutoff will be between 11/23 and 11/30. If I wanted to do 3 validations, I could say subtract 21 days here, and then that would allow you to do 3 validations. Or I could change these periods if I don't want them to be back to back. I could adjust them as I need for my data. But I find doing 2 weeks to be good enough. And obviously, every time you increase the number of cross-validations that you're doing, it's obviously going to increase the runtime. So This will take about 5 minutes to complete, and we'll pick this back up as soon as it's done. Okay, this completed. It took a little over 6 minutes for it to finish, but it made 2 forecasts between the time period that we specified. And if we look at the cross-validation metrics here, if we just look at the tail, we could see that it had the y-hat, y-upper, lower, cutoff, and so on. So this is the cross-validation output of what it looked like. Now what we want to do is we want to generate those metrics from all that data. And by default, it's going to use a 10% rolling window. This is actually really handy if we would like to look at the data, but we can also use a rolling window of 1, which we're going to look at in just a second for why we would do that to store it in our model. So the default rolling window, we made two validations, right, over 2 different weeks. And then obviously there's a lot of different time windows within each week. And the nice thing about this is that for each horizon, each time horizon is all of the error, like the RMSE, which is probably about the most important one we're going to look at, or the mean absolute percent error, MAPE. We can look at that as well. But if we look at basically the standard deviation of the error is probably the most important one, we'll see that over each time window, which is really handy to look at, as we'll see in some charts in a second. But when we're storing this in our model, we might only want a single value to represent the RMSE. So if I specify a rolling window of 1 as an example, you'll see that it collapses all of that down into one average for the entire time horizon. So that's what we're going to use to store in our model. So in the next cell, what we'll do is we'll grab all of those different values, and we're going to store those because we're going to store those values in our model in a little bit when we register the model with MLflow. So there we go. We have all of those values ready to go. And we can take those original metrics, though, and start plotting them out. And this is what's handy about having them rolling window, because we could see the performance over time and relative to the accuracy. So we could see where we start to lose control of the model. Does it stay pretty true? Are we hitting a problem with large spikes? That kind of thing. And so we can then look at the RMSE value, plot that out, and we can also see where our largest error is coming from. Does it happen later on? You can see that there's that real big spike that comes in midweek, right? Wednesday, Thursday, that happens. And that's the hard one for us to capture. We have the largest error around that time. So that tells us a few things that we could do. We could potentially look at our model and see if there's a strong seasonality there. It just gives us a point that we might want to look at and tune a little bit better. Now, this is taken from the Profit page, where they give some examples of how you can tune diagnostics. Now, by default, we're not going to run this. In fact, we could see the test parameters is false. If you want to run this, you can by changing this to true. But what this does is this takes a lot of the different variables, the 3 that tend to have the most impact, the change point prior, the seasonality prior, and the weekly seasonality, creates a matrix of these values and runs cross-validation across every combination of those values, and then prints out the results in a window. So if we were to run this, obviously this would be a lot of validation routines to run. So we could do it and then come back in however much time, depending on our cluster size. We could parallelize this, but it would take some time to run. And then we could see what combination tends to work best with our data. So with that done, what we can then do is move on to MLflow. And what we're going to do is create a experiment that has our stock symbol in the name. So in this case, you could see that it has the I don't give a darn stock prediction as the name of our experiment. Now, an experiment in MLflow, you can think of that as a container. It has all of the different runs that we're going to have. We haven't set up this. We've created the model, but we haven't created a run yet. We've only set up the experiment. So the experiment is there, but it's empty. And we could see that output there. And the next thing we'll do is we'll actually create our run which consists of our model that we already created, but then also we're going to log all of the different metrics that we had. So all of the input parameters, the change point, seasonality, and so on, and then also the performance. So as we work with this over time, we'll be able to look at the history of all of the different runs, and we can compare them. And the output of this will give us a URI that we can then use to load the model at a different point in time. So you can see that we register our model, we have it here. And so let's go ahead and then use that model to generate some predictions. Now, we have the model already loaded here, but the idea here is that we're coming into maybe this at another point in time, right? We have maybe a separate notebook, or somebody else is going to look at this and say, I'd like to load that model and then see how well it does against some data. So that's what we're going to do here is we're going to load that model from MLflow by using the model URI, and we can inspect MLflow, by the way. We can query that and see what experiments exist and what models are there. So we loaded the model, and then we're going to establish begin and end dates for our prediction. So let's just say we'd like to predict the next 1 week of data, right, between 12/1 and 12/8. So we'll do that here by having an begin and end date. And then we have to create a data frame in order to store our predictions, much like we've already done when we were training our model. So there's a few different ways we could do this. Now we're going to, just to make this interesting, we have the future data that we downloaded, and we included future data because we don't know when people might be running this example. So we wanted to make sure we had enough data created well into the future. So if you're looking at this now, if you're looking at this sometime several months from now, that there's always data for you to look at. So we have a little bit of an advantage, a little bit of a cheat, if you will, that we have future data that we can look at. So if I look at our data frame, looking specifically at the future, right? And we truncated this earlier before we trained our model, right? We said everything up until midnight last night, essentially. We could see that we have data for our stock into the future. So what we're going to do then is we're going to create essentially a pandas data frame, and we're going to copy all of those timestamps, but only the timestamps, into our data frame. So we have, and we're going to rename, by the way, timestamp to DS, just like we did earlier. And so you can see now that we have our pandas data frame has all of the timestamps in it, and then we're going to use that in our model to see how well it fits. So we're keeping our future here, the future data set that we had. We're going to keep that aside for a moment so we can compare how well it works in just a moment. So in the meantime, we have our pandas data frame that has just our dates that we'd like to look at. And another way to do this, by the way, is we can use that make future data frame function that Profit has built in to do literally the same thing. You can see that this matches what we did up here, right? Where we said, okay, from the future, give me all the different data points, and then column called DS. We could ask Profit to create a future data frame, again, once every minute, all day for 7 days. Give us a data frame to work with, and it will do that here. Obviously, we could also then write some code that loops through and generates all of that for us. I'm looking for the easiest way to get to the same result. So either one of those will work. Obviously, if this were more of a real scenario, we don't have the future data to work with. So I'd probably just say, hey, Profit, give me a future data frame. So what we're going to do is we're going to predict what the data will look like by passing in basically our timestamp pandas data frame. And we're going to look at the values that come out of that model. And similarly to earlier, we could see that it generates all of the y-hat. Again, we did ask it in our training to go ahead and develop all of that. So this should look very similar to what we saw before. And then what we're going to do is we're going to combine all of that data that it created, specifically the y-hat. We're going to disregard everything else. Not that all of this data isn't important, but for our purposes here, y hat is the predicted value. So we're going to combine our future data with the forecast. So let's do that now. Obviously, we're in a bit of a advantage here because we have the future data. Otherwise, we'd have to wait for it to happen. But what this generates now is it mashes the two up, and we have the actual price that occurred, and then we have the predicted price, or y hat, in one one pandas data frame. So next, we'll go and we'll actually plot this out, and we'll call this predicted versus actual. So we can see now this is data that Profit has never looked at, and we can see how well we did. So we could see that the red line, and this is the first time I'm seeing this as well, the red line is predicted and the blue is actual. It actually, I see some fairly decent correlation. Obviously, this is largely random data, and even if it weren't random and this were the stock market, I'd say we probably couldn't do a very good job modeling that either. But you could see that there is a fairly good prediction that occurs over this. There's definitely some seasonality. It missed some of this. Some of this seems to go pretty low that we sort of had modeled here, but and then also the highs aren't quite as high. So this tells me that maybe we need to be a little stronger on our seasonality, but at the same time, we don't want to overfit the data. So obviously a lot of room for exploration in how this works, but nevertheless, this is our first pass that we take in only a few minutes, right? So I'm pretty pleased with what that looks like. Now, the next thing we could do is we could look at the Scikit-learn metrics module, and then we can compute the RMSE, the MAE. We can compute all of that from our data as well that we looked at, that we created. We could see how well it did. And so if we compare, we look at the RMSE in particular, the last line, our model had an RMSE of 112.89. And you could see that our actual ended up being 119.12, essentially. So this is a way then for us to verify, now that we are actually, say, using this model, how well is it doing compared to how well it had done up until this point based off of what Profit said. So if these values were really, really far off, I might think that we're either overfitting or something is happening that we should take a closer look at. But these numbers match reasonably well, especially given the random nature of the data. And finally, in the notebook, the last step is we can inspect MLflow if we would like to, by the way, and then we can get the different predictions that are there, the different runs rather for everything. So we could see, I had run this before on the Who stock. As I mentioned, I'd already looked at that. This is the first time I'm doing it for this stock. And then we could see that the run is here that we can look at. So this gives us a programmatic way for us to look at all of the runs in MLflow that we could then load. So if we want to look at this in the UI, I'll go back to my workspace, and we should see, I'll refresh this. We see the Who stock that was there. Let me refresh my my screen. It should have the I don't give a darn experiment and model. Oh, here it is up here. I don't know if that was there earlier. I didn't see it, but here we have the prediction and the model for this for the I don't give a darn stock. So if I click on that and open it up, what it should show me is all of the past runs that we have, and then including all of the metrics that were part of that model. And this is by the way why we chose a rolling window of 1, because we only want, for our purposes here, we only wanted everything represented as a single value to make it easy to look at. For your purposes, you may choose to have a lot of values, right? We might want to compute, for example, the RMSE only for one day. All right, maybe our most important thing is how is this going to perform for one day, because it could be expected for the data to change greatly over, for our accuracy to decrease over a larger time horizon. So a lot of different variables for us to look at, but nevertheless, you can see that it's all logged here for us to look at. The input and output schema that we told it to infer from our model, so we can look at that output. And then if we only have this one model that we created, this run, but we could look at all of them and then plot out how well they do, so we can track the effectiveness over time. Okay, so that's a quick look at getting started with data science. That's a lot of of information to unpack. We looked at how we were getting the data into our Lakehouse, but we provide that data for you. So check it out. In our Fabric Real-Time Lab, we'll have the link here on the screen, but then also down in the notes. Check it out, download it. You can run this without any other, you don't need to set up the rest of the lab if you don't want to. You can, but it will download all of this data. You can go through it. Try creating your own models if you'd like to. You don't have to use Profit if you come up with a different regression that you'd like to do. And it looks interesting, let us know. We'd like to check it out. In the meantime, thanks for watching, and we'll see you next time.